All right. So again, hopefully you got your 9.7 outline of all of our tests. So looking at our following series, we're going to indicate a test that would be a good choice and does it converge or diverge. So looking at the first example, take a good look. Something should jump out at you. And yeah, that's right. Hopefully you said there's powers of n. So you should use the root test. What you should do is write this whole fraction to the nth power. So then you can take the nth root of this sequence in its absolute value. They're going to be all positive, so we don't need the absolute value. Then take the limit. All right, so here if you were to take the limit, the top power 1, bottom power 2, this is approaching 0. So that limit is 0. So therefore, this series is going to absolutely converge. So we can say that it's also going to be convergent or converges. Looking at example number 2, dead giveaway, the -1 to the nth power. We should do the alternate series test. So if we take off the -1 to the nth power, we notice we have n over n squared plus 2. So since n starts at 1, we have all positive terms, so that's a good thing. So now we go to our two things we have to prove in the alternating series test. Does the limit approach 0? All right, so again, looking at your leading terms, n to the first, n to the second, top power smaller than bottom power. So therefore this is approaching 0. Again, using that horizontal asymptote rule, so that's a check. And then we have to prove that this is going to be decreasing all the time. So a little quick review, you got to put n plus 1 in for both of those terms. You're going to have to cross multiply. So n squared plus 2 as a binomial multiplied to n plus 1 on the top gives you n cubed plus 2, n squared plus 2n plus 2. We would FOIL this out, add a 2, multiply it to the n. You would get n cubed plus 2n squared plus 3n. So again, on the left-hand side, we want to show that this is going to be a 0. So subtract over the n cubes, gone. Subtract over the n squared, subtract over the 2n plus 1n, subtract over the 2, minus 2. So since n starts at 1, 1 squared plus 1 is 2, 2 minus 2 is 0, so 0 is less than or equal to 0. And then after that, you put in 2's, 3's, 4's, it's just going to keep getting bigger. So yes, it's decreasing for all of our n, for n greater than or equal to 1, so therefore yes, it converges. Example number 3. You know, if that plus 1 wasn't there, you'd have n to the first power, and we can say that that is a p-series. So if I say it looks like I could turn it into a p-series, that's your comparison test. So this can be a limit or a direct comparison test. So with the plus 1 on the bottom, I'm kind of leaning towards doing a limit test. So let's see. So p equals 1, that means it's going to diverge. And now we take the limit. So my original function is 1 over 2n plus 1. Getting rid of the plus 1, my comparison is going to be 1 over 2n. So I divide by that, or check, multiply by its reciprocal. That gives you 2n over 2n plus 1. The powers on top and bottom of your leading terms are the same. The leading coefficient ratio is your limit. 2 over 2 is equal to 1. That's greater than 0, and it's finite. So that justifies the fact that we diverge. Number 4, the infinite series, n equals 1 to infinity. We have n squared times e to the negative n cubed. Whoa. Well, multiplying two functions, and I see an n cubed and an n squared, I would definitely look at doing the integral test here. Because if I let negative n cubed be my u, take the derivative of that and get negative 3n squared dx, and I can make my du be just negative 1/3 du. So this is a good component for doing the integral test. So again, am I continuous? Yes. Yes, exponentials are continuous from 1 to infinity. Are they both positive? Well, even though it's a negative power, if you think about putting it in the denominator, it's e to the n cubed, all positive values. Am I decreasing? E to the n cubed, I believe we'll be getting small, much bigger in the denominator than I am on the top. So yeah, I think it's decreasing the whole time, especially when this value in the exponent is going to be bigger than this term up here, and then you're taking e to that power, which is already bigger. It's by far decreasing in the worst way. So we'll set up our improper integral, change n's to x's. Like I said, negative x cubed would be your u. Your du will be negative 3x squared. So the negative 1/3, that's what I divided over when I solved for 2 or x squared dx. This is what's left over for the du. Integrate e to the u is just e to the u. So put back in the negative x cubed. Well, okay, I'm going to write that in the denominator as being a positive. The nice thing here is notice that it's missing the top part. That's good. All right, so what do we have next? Plug in your t. Evaluate your limit. So 1 over e to the t cubed. This is getting huge. This is approaching 0. So negative 1/3 times negative 1 over e, that's a constant. This is a scalar factor. I'm approaching 1 over 3e. So since I took the limit, since I took the improper integral and it's equal to a constant value, then it converges. Whoops. Example 5. Okay, dead giveaway here, 1 over n to powers. So I'm thinking this looks like a p-series. Drop the plus 1. Square root of n squared is n. Times this n, it's 1 over n squared. That's my b sub n. So that's a p-series. P equals 2. So 2 is greater than 1. This converges. So my b sub n converges. Now I have to do a limit or a comparison because I'm in the square root. This is looking ugly. I'm going to do the limit test. So a sub n, 1 over n times the square root of n squared plus 1. My comparison was 1 over n squared, so I multiply by its reciprocal instead of dividing by it. Multiply the n squared to the top, to the 1. That n will cancel into the n squared, leaving me an n. So again, as I take and look at the limit here, what I could do is I could divide all terms by n. So on the top would be n over n. When I take the n inside the square root, I'd be dividing by n squared. So I would get 1 on the top, then the square root of 1 plus 1 over n squared. Well, 1 over n squared is approaching 0. So that's the square root of 1. So 1 over 1, it does equal 1. It's greater than 0. It's finite. It verifies that it converges. All right. So that's this video. Then we'll do the next examples in our next video.